An informal definition of the commutative law is when the order we do the operation doesn't matter. So as we were saying above, if your operation is plus, minus, divide, multiply, any one of those possibilities, or even if you come up with a new operation on a new set, if the order that you do the elements in doesn't matter, so that's why we write A star B is the same as B star A, and if this is true for every single possible A and every single possible B, that the order doesn't matter, then we say that our operation is commutative. Let's again return to our happy face table and decide whether we have built a commutative operation in our meets table. So again, we're discussing happy, unhappy, and surprised, and they're meeting each other, and the result is given in the table. So is meets commutative? Now, you can easily see this by a little bit of a visual trick if you view a reflection along what we call the main diagonal. So if we draw a line from here going through down to the bottom, that's what we call the main diagonal. And if you notice that we have a reflection where surprised matches up with surprised, happy matches up with happy, and unhappy matches up with unhappy, we have what we call a commutative operation. It's a quick visual check to make sure every row matches up with every column. Or in other words, it doesn't really matter if you do what's over here first or what's over here second. You can switch the first and second. You could do the column first and then the row second if you like. So to answer our question, is meets commutative, we would say yes. Yes, meets is commutative. And how about we give a description of why meets is commutative? We will say that it is symmetric about the main diagonal. It is symmetric about the main diagonal. Okay, let's do some examples and decide whether we have commutativity or not. We'll take the set of real numbers. So there's infinitely many real numbers, and these are any numbers that you can say out loud with digits and a decimal place, and more digits after the decimal place. The fancy symbol that mathematicians use to describe the real numbers is this kind of funny boldface R. So we're going to be working within that set, and we're going to say whether or not our four basic operations are commutative. So is addition commutative? So if you take any real number and you add it to another real number, you can switch the order. Now this certainly makes sense for integers. If you're adding up objects, if you have 5 objects and you have 7 objects, you get 12 in total. If you switch the order around, if you do 7 objects first and then 5 second, you still have 12 in total. It gets a little bit more tricky when you think of real numbers, and you could have, any decimal place that you like, any weird real number, whether it's big or small or negative. But it turns out that this also works. Not that we can test every possibility, but it certainly makes sense with integers, and we can say that, by definition, this equality works. So I'm going to write by def for by definition. So there's a few starting places that mathematicians take towards algebra, and this is one of them, that addition is commutative over the real numbers. So we put that in our dictionary. Is subtraction commutative? Well, this one, maybe not, because we can do like 2 minus 1 is actually not the same as 1 minus 2. 2 minus 1 is 1, but 1 minus 2 is negative 1. So the top expression is not equal to the bottom expression. So is addition commutative? We say yes. Is subtraction commutative? We say no. Let's move on to multiplication and division. So for multiplication, a very similar idea as towards addition. If you take two numbers and you multiply them together, it doesn't matter which order you multiply the two numbers together. I suppose because multiplication is based on a definition of doing addition, and if you're doing addition over and over and over, you get multiplication. If the order doesn't matter for addition, it also shouldn't matter for multiplication. But again, I think it's fair to say that this is, by definition, we write this into our dictionary for a mathematical law to start with for real numbers. Is division commutative? Okay, now we can come up with a counterexample again. We could do 1 divided by 2. Well, you get 1/2, but that's certainly not the same as 2 divided by 1, because that's 2. 2 is not the same as 1/2. So, is multiplication commutative? We would answer yes, but division is not commutative, no, because we can find a counterexample.